it doesn't say stop.
Kellen, on that conversation, you know what I think? Those freshmen or sophomores should just be good enough to work their way up to the team. Not
Yeah, they are.
Then show the coach. I got two sons and both of them play baseball
Yeah.
and all, guess where they played all 4 years?
JV varsity.
Started varsity all 4 years.
The baseball coach.
And golf.
I'm getting tired of this thing. And that's how it's
That'd be
going.
really fucking good.
That's so beautiful.
Playoff. They don't have to-
Dude, there's somebody here.
So he's gonna turn me into a pitcher.
Imagine Branson pitching.
I'm so. Every time I pick up tongs.
This is him right here. You like football?
I really was.
Sound like a male tennis player.
Very bad team. Because dude, my mom snores. My computer living garage sitting in the living room.
I've never played baseball a day in my life.
Germantown, and I wake up I'm like,
Dude, my grandma lives in Germantown.
yeah. All my half of my
Grandma
mom's
lives
side
in
lives
the
there.
ground.
They live in the. My grandma lives in like I think it's called some apartments.
I'm like right beside the.
Behind a McDonald's.
Ah.
Hey,
It's kind of awesome.
you know
Really
the
nice.
motel
I'm sure you know that.
My grandma lives in Germantown.
I'm living in
the
Where?
motel right next to it.
Where?
My gas station also.
Yeah.
You can get
Little-
it's considered wine, but it's like.
What are you laughing about?
There
There's
are
already
these-
this
It's considered eaten, but it's like right next to you. But that motel's.
That doesn't mean I take directions from you.
At
Like,
Germantown?
put yourself in.
No.
You know how to.
Questions on page 167.
You're like
Number 12.
What? Okay.
Number 12 says, get a free water bottle with 1 year membership. Get a free water bottle with with a year membership, whatever it says. What has to come first there? This is what you gotta watch out for when you're writing these if and then statements.
The 1 year.
The 1 year membership. So what's the if part? The hypothesis gonna be this time.
If I have 1 year membership.
If 1 year, and I don't mind, again, I'm not taking grammar here.
I wrote somewhere.
So if, you should, because it helps you in English class and everything else, but I probably won't take off points for your grammar, right? So if 1 year membership, then what?
then free water bottle.
Then free water bottle. And what else did they ask us? They said identify the hypothesis and conclusion and write each statement. So we wrote it if and then for. Oops. That's the what? Hypothesis. This is the conclusion. And this time I don't think they asked us to tell if it was true or false, right? Next question.
22.
22.
It says 89 is an even number if it is divisible by 2.
And what's it want us to do? What's the direction say?
Write the conditional and converse for each statement.
That was number 12, wasn't it? It wasn't number 1. Right,
Conditional and converse for each statement. Determine the truth values of the conditionals and converses. If false, find a counterexample. Write a biconditional statement if possible.
Alright. So 22. We won't do, I told you last time, we won't do a whole lot with biconditional statements. Again, all a biconditional statement is if the statement is true and the converse is also true, then it can be written as a biconditional. You can say it. In other words, that's that. Where we had the double arrow thing, sorta, that's where it works both ways, is all it says. So this one, 89 is an even number if it is divisible by, if it is divisible by two. So how am I gonna write that as an if and then statement?
If it is divisible by two, then 89
Does everybody agree with that?
That's what I, yeah.
Alright, so that's a if and then statement. Did they want us to identify the hypothesis and conclusion this time or not? I don't think so. They want to know, is this true or false? Is this true or false?
False.
So if it's divisible by two, then 89 is an even number. 89 is not an even number, right? So it's false.
But it goes up to 44.
It is divisible by two, it just doesn't come out to a whole number.
Right.
Yeah.
It has to come out to a whole number.
So they probably should have explained it a little more. They should have probably said it has to be a whole number to be, because everything's divisible by two, right? You can divide anything by two, it's just. Then, it says, write the converse. What's the converse do to a statement again? Flips it, so what's it gonna say?
If 89
If 89 is even number,
then it's divisible by 2.
then
And divisible by 2.
it is divisible by two. Is that true or false?
True. False.
False.
Right.
I'm sorry.
Now, they said write it as a biconditional, but we can only write it as a biconditional if both these statements were what?
True.
True. And since they're both false, is it gonna work as a biconditional?
Nope.
No. So that's it for that answer.
Okay.
So, for like, stuff like 19, 20, 22, 23, and 26, is it really just that easy to say true or false for those? Is that all I have to do?
Yeah.
So 19,
20,
what do you mean, is it that easy?
Like I said, just,
19, they wanted you to write the converse, inverse, and contrapositive.
oh,
Man,
So you had to write 3 different sentences. And then, once you write out those sentences, then you're telling whether each one is true or false. And those are the problems. I was saying, is there enough room to write 3 sentences here in the book? That's why I didn't want you to write them in the book, because there's absolutely no way that you should have been able to write that, write those in the book if we were doing those. I don't think we did all those, though, did we? We did like one of them or something, didn't we? 19.
and 20,
Oh, we
and
did
22.
19 and 20.
Oh, wait, never mind, 22, I think.
22 was the one that we just got to do. Brandon's going back to his old ways. Here in a second. Guess what she's last week did.
22.
Other questions?
Well, I don't know what my problem was with 29, but I just couldn't get it. What is the truth value? What does that symbol mean?
29 says, let's see. What is the truth value of, so let's do this. What are our options? Erase everything. Give me a second to write this out, however it says it here. It says, parentheses. Did I write that right? Yes, no, maybe?
Yeah.
They tell us P is true. So we don't know what the statement P is, but we know it's true. Q is false, and R is true. So as we're looking at this, just like in algebra, we do what's inside the parentheses first. So it says not P. If P is true, then not P has to be what?
Not true.
False.
So it has to be false. What's this symbol mean again? Or? Does everybody agree with that? Q was false. So just in the parentheses, all that stuff in the parentheses there, we got a false with the word or and then a false. Is that whole statement true or false?
True. No, false.
False, right? So then we got a false statement. What's this symbol? And they tell us R is true. So we got a false statement, the word and true. So what do we know about that whole statement there?
It's false.
It's false because with and, both parts have to be true for the whole thing to be true. So what do we know about all of it?
It's false.
If you didn't grab the notes up there, grab them. Starting to get into stuff that you're probably going to find a little more difficult. Two things that we covered today, not really all that difficult, but sort of confusing. So Branson's going to, I have to tell him away from you.
Wait. Can we do 22?
He's such a everybody didn't understand your joke real well.
Yeah, how did you not? I didn't know Will Smith was a rapper.
Didn't have nothing to do with him being a
Because we live in a
rapper.
box.
Had to do with him being the Fresh Prince on a TV show.
Yeah,
I thought you said he was a rapper.
He was a rapper.
but that
So he
wasn't
was-
what the joke was about.
And he didn't say cuss word.
I'm
Smith,
lost.
did he say cuss word?
We know that, Branson.
Been lost for a long time.
Stay with me on the geometry stuff. I don't care about the Will Smith stuff, on geometry.
Yeah.
That's where all your brain power needs to go to, all right?
Good.
Doesn't have major.
I just got the image of Will Smith smacking that guy.
Hey, can I throw an alley-oop to Luke?
That's right.
Oh my gosh.
50 push-ups.
All right, last time we talked about inductive reasoning. Somewhere on your notes there, right above deductive reasoning or somewhere, write inductive reasoning. So somewhere in a little space anywhere, write inductive reasoning. To remember the difference, to help you remember the difference. Last time we talked about inductive reasoning, sorry, can't write up here. Give me one word to help you remember what inductive reasoning deals with.
In.
Pattern. So if you're dealing with patterns, you're using inductive reasoning. If you're dealing with stuff like rules, you're using deductive reasoning. So inductive reasoning is seeing something happen over and over and over and over again and then making a decision from the pattern. Deductive reasoning is using some kind of mathematical rule or any kind of rule. All right? So inductive reasoning, example of inductive reasoning might be Luke goes to the bathroom every time before class and he knows there's always too many people in there, so next time he just decides not to even walk down there. That's using inductive reasoning. All right? Because you see that pattern, so you make a conclusion or draw a conclusion from that. Deductive reasoning would be something like
Trying to solve it.
Mason says a curse word and Ebersole throws him out of class.
That's a rule.
Because that's a rule. You can't be using foul language in here. All right? So when we're dealing with math, which one are we gonna use most of the time?
Deductive?
Deductive. We're gonna use our rules. Alright, and some of the rules are stuff like, you know that a right angle has a measure of what?
90 degrees.
90 degrees. You know that a linear pair, add up to
180.
180, so on and so on. All those rules that we've been learning. You know that supplementary angles add up to 180,
Yeah, okay.
so on and so on. All those rules. That's using deductive reasoning. The process of reaching a specific valid conclusion based on general facts, rules, definitions, properties. A valid argument. A valid argument is an argument, or an argument is valid if it is impossible for all of the premises or supporting statements of the argument to be true, and its conclusion to be false. So, all I'd say, it says a whole bunch of crap there, and Michael probably didn't understand any of that, and that's fine.
I'm just writing it down.
A valid argument. What we're saying there is, you gotta be able to back up what you're saying. Cameron goes home tonight and he asks his folks for $20, what are they gonna say, Cameron? Why? They're for sure gonna ask why, right? Even before they say no, they're gonna ask why. Even though if they know that they're not gonna give it to you regardless, they're still gonna ask why. And you gotta have a valid argument. You gotta be able to give them some kind of reasoning why you need that money.
Step through.
So did you write it again?
Yeah.
Silly.
Mr. Ebersole, we have a valid argument about who the best point guard of all time is.
Oh my God.
After, we will here in a minute.
Really?
Alright, but what are you gonna have to give me to have a valid argument?
Evidence.
Some kind of evidence. You're gonna have to use stuff to show things. Inductive reasoning, patterns, deductive reasoning, rules. Remember those two things. Venn diagram. A lot of times we use a Venn diagram as different things. I put this on here, you can draw that Venn diagram, I'll give you a minute. It's nothing hard about a Venn diagram, it's just,
Circles.
some people have seen it, some people haven't, so I put it on in the notes.
Okay,
I'm hoping that all of you have seen a Venn diagram before.
so all squares are rectangles?
Is that what the Venn diagram says?
I think that's what it's saying.
Well, it looks like, isn't it? So if I pick a shape that's right here, Luke, if my shape's right there,
It's a rectangular polygon.
is it a square?
Yeah.
Yes.
Is it a rectangle?
Yeah.
Is it a polygon?
Yeah.
Yeah, it's all those things. Is it a pentagon?
No.
No, apparently not.
Pentagons be weird.
You're always so quiet. If you nod, I can open it.
Well, I can't have square again.
How come a square can't be a pentagon?
Just know that 5 sides.
A square has 5
I
sides?
Yeah.
Branson, you should not try to be a smart aleck because you get yourself and then you look silly. So, this is a Venn diagram. A lot of times you'll see Venn diagrams that look like this. What's that tell you about these people here, or these things
They're
here?
the same.
They're the same?
No, they like, that's what they have in
share
common.
the same.
If this is group A, this is group B, what do we know about these people?
They
They're
share
both-
similarities.
They're both.
They're in both groups. They're in both of those sets. Alright? What if I have another one like this and this is group C?
They're all three.
What do we know about these people right here in this little part?
They're the same as
Everything.
They're in all 3 groups. Alright? Now, again, you guys are saying they're the same. Same as what? I'm not sure what that really means. But we do know that they're in all 3 groups, whatever those groups are. Alright? So be able to look at Venn diagram, any Venn diagram. What if I gave you a Venn diagram that looked like this, and this was group D and this was group E? What do we know about those 2 groups?
They don't share anything.
Don't share
in common.
anything.
Alright, they don't, nobody's in both groups or nothing's in both groups. Same thing here. What kind of shapes in the group that's pentagons and in the group that's rectangles?
They don't share any.
Alright, there's no shape that's in both those groups at the same time. Are there other circles I could have put in here?
Yeah, sure.
Yeah.
Like a circle.
Hexagon.
Could you put a circle in there?
No.
Yeah. No, it's not polygon.
No, it's not a polygon. Circles would have to be their own group out here somewhere, right?
There's a circle in there.
You could put a hexagon, so you could put the group of hexagons in there, so on and so on. Lawyers often use, I don't know, is there anything to write down on this? Probably not, probably.
Oh, no,
Is
Yes,
there?
there is.
Alright, I'll give you a second. Just a couple of things. Yeah, I might see some sort of thing, like this. We're doing that next week, so.
Look, I made a smile face, I don't think that's great.
I'm so proud of you.
What did I do? We're hanging out this weekend? We are. We can do that like for 3 hours.
So lawyers often use deductive reasoning and the rules of logic to create persuasive arguments in court. Deductive reasoning can be used to draw valid conclusions from evidence and prove the subjects are either innocent or guilty. You can also, as a lawyer, use logic to determine when the other side doesn't have a valid argument. Alright, so when Ethan ended up here says, oh, this stuff's all stupid, I ain't never gonna use none of this. Number one, if there's anything in geometry that every single one of you is gonna use, I hope, logic, deductive reasoning, inductive reasoning. If you're not, then
Direct common sense.
you're right. Determine whether each conclusion is based on inductive or deductive reasoning. We're just gonna write down the answers. I think these are in your notes there, aren't they? If a student is late returning a library book, then he or she will be charged a $2 late fee. Chang returned a library book late, so he concludes that he will be charged a $2 late fee. Inductive or deductive reasoning?
Deductive.
How come deductive?
Because he like assumed, like,
It's a rule.
It's a rule. You're using a rule. It's that easy. You're using a rule. Every time Tamika has worn her favorite jersey to a football game, her school's team has won the game. Tamika is wearing her favorite jersey to the football game tonight, so she concludes that the school's team will win the game.
Inductive.
That's an inductive.
Good job.
Pattern. Is that using some kind of rule?
Pattern.
It's just a pattern.
Jeez.
Using a pattern.
He just caught on to what was going on, so now he's screaming it because he
Nah.
Just wants to show that he's intelligent.
Oh, yeah?
Because I make fun of him all the time for the silliness. So now he's trying to turn it around, right?
Oh yeah.
Yeah.
Oh, man.
At least you don't make fun of my hair.
Your hair doesn't
Some
look
teachers
bad.
do.
Oh, what? Okay.
Who makes fun of your hair?
King.
Mr. Cheney made me laugh the other day because he was giving us one of his lectures and he goes, all you gotta do in this class to get an A is participation and attitude. That's all you need. And then he said, I'm a butt kicker at everything I do, and if you're not, you aren't gonna get a good grade in my class. And I was like, what?
He
Yeah, that's
he
what
calls
said.
me out every class, like 5 times every class for no reason.
It probably means that he likes you.
So
Come on,
I work-
Branson.
I work-
There's really no reason.
Okay,
Always called
so
me
we
out.
played basketball last week. And literally, he said that I threw a fit over a traveling call. I traveled one time, and I was like, I dropped the ball. I was like, I traveled. He was talking about offense.
Were you like her in?
Huh?
Oh yeah.
I traveled
I
on.
wore a step on jersey once in his class, and all he's been talking about since is Brittany Griner. I'm like, what is that? He said, oh, I bet you like Brittany Griner. You can get you Brittany Griner jersey for Christmas.
All right, we're gonna cover.
I said yes.
We're gonna cover 2 laws today. This is the main part of the lesson here, and this is the part where you gotta listen closely, or you probably will get lost. So Branson's gonna help me out and listen closely to this. These 2 laws aren't hard, but they seem to confuse students a lot, right? The law of detachment. What's detachment mean?
To take away, detach,
Not take away, but
Separate.
take,
separate.
separate, take
Another
apart.
word.
This is all the law of detachment is. Just watch what I'm going to show you here. We have a statement, PQ. That's like saying if P, then Q. We talked about the if and then statements last time, right? So we have to have this to use the law of detachment. That, and we know this is true.
I thought you were trying to erase it.
All right? Then the second thing that we gotta have is we have to know that P, all by itself, the hypothesis of that original statement, is true. And what the law of detachment tells us is that if we know this whole statement is true, we know that the hypothesis all by itself is true, then guess what we can say about the conclusion all by itself? It has to be true. That's the law of detachment. All they're saying that, all we're doing here, watch closely, you have the original statement. It's got 2 parts.
Okay.
We're detaching them. And we're saying the hypothesis, the first part, is true all by itself. Then that tells us that the second part, all by itself, has to be true.
So
That's what the law of detachment says.
P was false, then Q would be false.
So if P was false, then this wouldn't work.
Oh,
We can't say anything.
oh yeah, okay.
Alright? Now what if I did this? If A, then B. I tell you that's a true statement. And then I say B all by itself is true. Is that going to fit this law of detachment?
Yeah. What? Yeah. No,
What'd you say?
why not?
Why not?
Is A false?
We don't know about A, do we? So the way it's got to go is you got to know the whole statement is true together, and then you got to know what by itself is true. The hypothesis. And if that's the case, then you can say the conclusion all by itself is true. All right? But what's wrong with this one? All right, it's sort of backwards and it doesn't work. So if we look at this, a couple of examples here. If a car is out of gas, then it will not start. Is that a true or false statement? That's true. Sarah's car is out of gas. What conclusion can we draw from that?
She needs to put gas in it.
You're not helping.
It was out of gas.
If it's out of gas, what can we draw from that?
It won't start.
It will not start. Sarah's, so write that down. Sarah's car will not start.
I just broke a care.
No problem with it.
That's a conclusion that we can draw. Now looking at it, this is why. The hypothesis this time was car's out of gas, right? Then we knew it would not start. What do we know about Sarah's car? It's out of gas. You see how this first part, the hypothesis is what we're saying here. Then that means the conclusion all by itself would be true. So we know that Sarah's car will not start. Doesn't work backwards. So when we do this, a car is out of gas, then it will not start. You guys already told me that is true, correct? Sarah's car won't start. Is that the hypothesis or the conclusion?
The conclusion.
That's the conclusion. So we know that Sarah's car won't start. Does that mean we can say her car is out of gas?
No.
Is there many other reasons that her car might not start?
Yes.
Yeah. So this whole thing, we can, for this is what I want you to write. No conclusion. You can't draw any conclusion there because it does not fit the law of detachment. So again, looking at the law of detachment, if A, it's got to look like this. If A, then B, and we know that that statement is true. Then we know that A all by itself is true. What conclusion can we draw?
B's true.
That B all by itself is true. Don't make this harder than it is. You guys are looking at me like, whoa. If A, then B, they're going to give you that sentence,
Yeah.
all right? And we may have to decide if it's true or not, but if it is true, and then we separate off the hypothesis all by itself, and it's true all alone, then that means we could separate off the conclusion all by itself, and it's got to be true all by itself.
Okay.
That's the law of detachment. Again, what's detachment mean?
Separate.
You're just separating the parts. You're taking the hypothesis and the conclusion apart from each other. Did you get it all, or did you want me to go back? Good. Got it. Determine whether each conclusion is valid based on the given information. Write valid or invalid. The valid, invalid, this book does that. I usually write no conclusion or tell what the conclusion is. So A here. To go on the field, a student must turn, to go on the field trip, student must turn in a permission slip. Mariana turned in her permission slip. What's that telling us?
She can
Go
go
on
on
the
the
field
field.
trip.
Can she go on the field trip?
Yes.
Do you see how we separate those two things?
Yes.
Now, look, if we go back, you gotta be careful. What was the actual hypothesis? And
Must turn in permission slip.
Yeah.
this is the hypothesis this time. It's sort of backwards, isn't it? So we would say if a student turns in their permission slip, then they can go on the field trip, right? So just like when we were writing the if and then statements on the homework last time, we sort of have to switch those two around to get that. So that's the hypothesis. Then we said Mariana turned in her permission slip. That's the hypothesis from up there. And it's true, she turned it in. Then what do we know about Mariana? She can go on the field trip. So identify the hypothesis and the conclusion in each thing. Make sure it's in the order you want it. Then look at it and analyze it.
Oh, yeah. Oh, can you go back?
So the two steps you gotta do. Figure out where your hypothesis and conclusion are at. Then just analyze what you want, what you're trying to draw from that. Handle that, Cameron. Stuff's easy. It's not here today, is it?
I'm here.
that we're doing today. They're not real difficult, just got, most of them just use a calculator.
Oh, I caught that. I'm that good. That one I could have been like money down the drain.
Yeah, probably next week.
Wait, what'd you
Try
have?
to finish it today. I put it all into the stuff. Everything going on. On this, next one, this one you gotta fill in. If a figure is a square, then it is a polygon. First, let's identify the hypothesis and the conclusion. What's the hypothesis this time?
If a figure is a square.
Be careful now.
Oh wait,
What do you wanna leave off of that?
There is no.
What do you wanna leave off of that?
figure.
So you just want from here over, right? You don't wanna leave, don't want the if with it.
If it's,
A square is a polygon.
So,
A
a figure is a square, that's the hypothesis. Underline that and write that. What's the conclusion?
it is a polygon.
It is a polygon, that's the conclusion. So write that in. I got figure A here in my hand and I'm telling you it's a polygon. Notice we separated this off, didn't we?
Yeah,
We
no,
separated this part off
that's wrong.
and we're saying it's a polygon. Can we then say that the figure is a square?
No,
No, why not?
because it can be a pentagon, it can be a
It's
hexagon,
going
it
backwards,
can
isn't it? This would have to, this had to be the hypothesis and it's not. It ends up being the conclusion, so does it work?
No.
So what we wanna write here is not valid or no conclusion or something of that nature. We can't say that this is valid. We can't say that figure A is a square from the information that we have here. Does everybody see why it doesn't work?
You are using a conclusion?
Right, that's the mathematical reasons, but look at it common sense wise. If a figure is a square, then it's a polygon. We know that that's true. I have figure A here in my hand, and I'm telling you it's a polygon. Does that mean it has to be a square?
No.
It could be a triangle, rectangle.
Could be any of those polygons, right? What if I changed it and said, figure A is a square?
It's true.
Then that's true now. Figure A, I got it here in my hand, and it's a square. What conclusion could I draw?
It's a polygon.
Then we know it's a polygon. That's the law of detachment. It works one way, but it didn't work the other way. Next law of syllogism. Law of syllogism.
That's a word.
Syllogism.
It kind of does look like it's food.
Fill in what you need to fill in on that.
Or like a skill. I need to use the restroom so bad, but it's so early in this quarter that I don't want to fill it.
It's a hard part of crap.
Yeah.
I thought I seen her on the
You
app.
tired?
She's not sure. Michael.
Huh?
Law of syllogism.
Are you?
In algebra, you learned this rule, and we're gonna do it next week. A equals B, and B equals C, then what conclusion can you draw?
A equals C.
Then A equals C. That was called the transitive property, alright? And we're gonna go back over that next week. So, law of syllogism, Kellen, you're getting ready to move. Law of syllogism is sort of like that. Alright, so it's a little different than the law of detachment. Law of syllogism, you have to be given two complete statements. You got an if and then statement here, and another if and then statement. Notice in these if and then statements, this is the what? Hypothesis. Write that down there on your paper. Underline that and write hypothesis.
Contagious.
This is the what?
Conclusion.
Conclusion. Write that down. So for our first sentence, we have the hypothesis, we have the conclusion. Notice, in the second statement, this is the what? Hypothesis. Have we seen that anywhere before?
The conclusion.
It was the conclusion up here, wasn't it? Same thing with this. When you did the law or transitive property last year, this, the end of the first statement and the beginning of the second statement had to be,
Same.
they had to be the same. That's the same idea here. This conclusion, to use the law syllogism, has to be the same as the second hypothesis. So those two have to be the same. If they are, what's this called in this second sentence?
Conclusion.
Conclusion. Notice what you did in algebra, if these two were the same, you just took this one and stuck them together, right? The two ends. That's the same thing here, and that's what our valid conclusion is going to be. So we know that these two are the same.
If you get a job, then you will buy a car. If you
So,
buy a car, you
so
will
what we're going to do is we're going to stick this part
buy a car.
with this part.
Actually, that's the next part, actually.
So if you get a job, then what?
Then you can buy a car.
Then
You
you
will buy a car.
will buy a car. And what we know is we now know that that is a true statement. From what we were given, we know that's a true statement. So again, just looking at some letters, if I do this, if A, then B, what's my hypothesis in this case?
A,
A, what's the conclusion?
B,
B, alright? So if I'm gonna write a second sentence, if,
B,
what has to be the hypothesis in this one for this to
B.
work? If B,
Then C.
then C. Something like that. If we're given those two statements using the law of syllogism,
If A, then C.
then we can conclude that the statement if this part put together with that part, if A, then C has to be a true statement.
Wow, I just realized that.
So that's it's like the transitive property. You're just, if those two middle ones are the same, then you can stick the first part of the first sentence with the last part of the second sentence together, and that statement has to be true. So if we went through this, if you get a job, then you will earn money. Is that a true statement?
Yeah.
Yeah, it seems to be. If you earn money, then you will buy a car. We're saying that that's true. I don't know if you want to buy a car or not, but for this, we're saying, okay, you're going to buy a car if you earn some money. So if both those statements are true, then we got this last thing down here. So if you get a job, what are you going to do?
get a car.
You're going to buy a car.
Okay.
That's going to end up being a true statement. Scientists have found that.
Pardon me, teachers, for the interruption. At this time, if I could have freshmen with the last name S through Z, freshmen with the last name S through Z to come down for hearing and vision check in the high school comments. Thank you.
Are they doing sophomores too, I wonder?
I don't know.
Sure.
If they are, we better hurry up and get done, right? So that if they
No,
start calling
it'll
you
take a
guys.
while.
Yeah.
It'll take till.
So
like-
sleep scientists have found that the quality and amount of sleep greatly impact learning and memory. Lack of sleep causes students to have trouble focusing and receiving new information. We can't see that in our class, right?
Not at all.
Nope.
Walk up next to him and then yell at him and see what he says.
I don't want to yell at Ethan. He's still with me, right, Ethan?
Yep, seems with you to me.
I'm gonna start taking
He's
pictures
listening.
of you though and sending them to the house.
Yeah, at least he's.
If your grade starts falling, is your grade gonna start falling? Alright, I'll trust you.
His dad.
He shook his head. He said,
Will his dad be?
It was not funny. To look at how.
He said my mom would beat me fast.
Your dad,
Going over to
so,
the house.
so,
I think I'm gonna shoot
let me,
myself.
I'll grab my phone here.
Dude, your dad's gonna shoot me.
Just to have some insurance.
I already have like three.
Dad's saying
I'll send you some.
Alright.
I'm gonna go come from kids.
Lack of sleep causes students to have trouble focusing and receiving new information. Sleep deprivation also makes it difficult to retrieve previous learned information. So from this, what can we decide? This is just using some common sense.
The conclusion is that sleep deprivation also makes it difficult to retrieve previously learned information.
Alright, so if we look at this, amount of sleep impacts learning and memory, right?
Yes.
Lack of sleep causes students to have trouble focusing. Sleep deprivation also makes it difficult to retrieve previously learned. So what did you say again, Luke? Say it again for him. What's the conclusion that we can draw?
Sleep deprivation also makes it difficult to retrieve previously learned information.
That's true. Give me something though. What can we say from all this?
If you don't get sleep, then it's gonna be hard for you to focus, get new information, and retrieve
Yeah.
previously learned information.
So we started off with this. The lack of sleep causes us to not be able to do what?
Retrieve previously learned information.
Learn and use previously learned information. Alright? And that's an example. It wasn't written as if and then form or anything, but can we draw that using deductive reasoning?
Kinda, yeah.
Yeah. Alright, now this one actually uses the law of syllogism, sorry. Couldn't remember what law we were dealing with. It's pretty bad, isn't it?
Yeah.
How does that use the law of syllogism?
I don't know, let's see.
It doesn't.
If you like musicals, this is called the what? Hypothesis. So underline that and put hypothesis. Then this is the what?
Conclusion.
So then you enjoy theater productions.
If you were an actor, is the same.
What's,
It's not.
you are an actor, is that the hypothesis or the conclusion?
Hypothesis.
Conclude. What?
It's the hypothesis.
Hypothesis, right?
Hypothetical.
Then you enjoy theater productions, that's the
Conclusion.
conclusion. Does this fit the law of syllogism?
No,
No, why not?
because the conclusion in the first example isn't the hypothesis in the second one.
To fit that, this and this have to be the same. Are they the same?
Nope.
Yes, sir.
So can we draw a conclusion from this?
It's
So what you write, no
conclusion.
conclusion or no valid conclusion. Now, could you draw a conclusion if you wanted?
Yeah.
Yeah, Mason over there could draw any conclusion he wants. Doesn't mean it's a valid one.
Can I say no verdict?
No verdict? No. That's something different.
So can we have an argument now?
No verdict.
So,
No decision.
let's look at it. If we tried to draw a conclusion from this, it would say, if you like musicals, then you enjoy theater productions.
That's our original statement.
That's the original statement. Are we drawing anything or making up anything on our own? No, we just went back to what they originally told us. So that's why it makes no sense whatsoever to do it. And I guarantee some of you will do that. I'll put a problem on the test and they'll say something about this shape is a square, so on, so on, so on. Give me a conclusion. The shape's a square. No, I already told you that. That's not a conclusion. That's what I told you. So you can't do that. The assignments on page 175, 1 through 9, 11, 12, 13, 15, 18 through 22, so on, so on, so on. Do we want to do some of these together or you want to
Who's the best point guard of all time?
be on your own? Do them on your own? You guys don't know half the point guards that ever even played.
Yes, I do.
Okay.